Hello and welcome back. And in today's lecture, we are going to discuss about the solid oops principles. What are they, and what is the their significance in the object-oriented programming language? What these principles contributes, how they contribute to write a reusable code, a maintainable code, a scalable code, which is maintainable as well, right? So all these things we will discuss in this series. In this particular small playlist, we will be having the understanding of solid oops principles. So in today's video, we are just going to understand what are they, why we need them, okay, and who invented them, and what is the purpose of having the solid oops principles, why you should know about the solid oops principles, how they help you. So all these things we are going to discuss in this video. And later on, from next video, we will be starting one by one all the solid oops principles. Okay, so there are five principles. Solid oops principles are five principles which helps us to write the maintainable, reusable, scalable code using the object-oriented programming language, any object-oriented programming language. Okay, so in the object-oriented programming language, or you can say the object-oriented paradigm word, these principles helps you to write a better code, which will be easy to maintain later on in terms of scalability, in terms of maintainability. Okay, so let's start with one question that I have for you, and you can pause your video for a while after looking into the question. So the question is, what is the most important feature in a software? When you are developing a software, when you are developing a product, what is the most important thing you should take care of? So there are four options I have given: scalability, performance, correctness, and maintainability. So you can pause your video for a while, and you can choose your answer, and then you can come back. So I hope you might have paused the video and you could have chosen your own answer. So match your answer with my answer, whatever I'm going to tell you. So the most important feature, or the most important thing you can say in a software or in a product, is the correctness. It should work correctly. Okay, so working correctly or not, this is your responsibility as a developer, as a designer, right? It should work correctly. As a developer, you need to take care of like all the algorithms, they are correctly written. There should be no bug, there should be no exceptions, there should be no memory related issues. All those technical aspects that you need to take care of while writing your code, that is your own responsibility. That doesn't have to do anything with the solid oops principles, let me tell you. But this is the most important thing: correctness. When you have written a software which is working correctly, maybe you have written a software which is working correctly, but later on you realize that when the load is increased on your system, then your system gets hang. It is not working properly. It is not working as expected. Sometimes it is getting hanged. Sometimes it becomes unresponsive, and sometimes it is crashing. It is not even responding, right? It's giving the memory issues. So all these things comes up after the correctness. You need to take care of these things. You need to check these things. That is why the performance testing or the load testing is done. So this is one of the aspects after the correctness. This is one aspect. The second aspect is that you want to scale your system. Earlier it was working for 10 or 5 modules, 10 or 100, or you can say the 50 users. Now we have to scale it to accommodate more than 1,000 users. I mean, you have to scale it. You already know that my system's performance is for only 50 people, 50 users, but now I have to extend it. I have to scale it to meet the requirements of the 100, or you can say 1,000 people, right? So that becomes another thing. So it should be scalable. And while scaling, suppose someone says that I have to scale it, and while scaling you feel that the code is not written in such a way that you can easily scale it, then can you call it a good code? No, you cannot call it a good code, because this code is not maintainable. It is not, you are not able to maintain it. You are not able to add new features. You are not able to scale it. Forget about scalability. Sometimes it may happen that you have to fix some bug, and you find that fixing this bug, although the bug is very simple, you can find out the root cause easily. You can find out the reason of the bug easily. Then you reach out to the root cause of the problem, and then you find that no, I cannot fix it. I cannot easily fix it. If I have to fix it, I need to refactor the code. I need to rewrite the entire piece of code in a different manner. So can you say this is a good code? No, it's not a good code. Your code should be written in such a manner that it is already maintainable. So maintainability, scalability, and the performance. All these things are impacted by the fact that you have written or not written a good piece of code. You have followed certain rules, regulations while writing your code, while writing your classes. Have you done that or not? So all these things you need to take care of. So for that, there was a programmer. There is a programmer whose name is Bob Martin. People call him Uncle Bob as well. So he has written some principles. He put forth some principles in front of us, which are related to the object-oriented paradigm world. So these principles are known as the solid principles, solid OOPS principles. Okay, so the solid OOPS principles are under the umbrella of object-oriented programming language, under the ambit of object-oriented programming language. So whosoever is working on the object-oriented programming language, they can follow this principle, the object-oriented programming principles, to implement the solid OOPS principles. So to take care of the writing the code, to take care of how I should write it, what things I need to take care of while I'm writing a new class, while I'm extending the things, what things I need to take care of. So all these things, they are they have been explained in the solid OOPS principles. So what is the full form of this solid OOPS principles? So S stands for single responsibility principle, O stands for open close principle, L stands for Liskov substitution principle, and I stands for interface segregation principle, and then comes D. D stands for dependency inversion principle. So this is all about the introduction of solid OOPS principles, and you might not be aware about these principles. Even if you are aware, please be with me. You will be able to understand it in a better way. We will have some piece of code as a sample as well after all the principles one by one. As soon as we will discuss one by one each of the principles, like once after the discussion of the single responsibility principle, I can bring up some code, maybe in C# language, maybe in C++ language, maybe in both. I can give you some sample code. I can write it here, and I can let you know that how it is written, right? So all those things I can show you. So after discussing, we will be understanding that how a class should look like if we are following the single responsibility principle, how a class should look like when you are following the open close principle, and similarly for others. So all these things we are going to discuss in the coming videos. So be with me. Have a nice day, and bye bye. And please like, share, subscribe my channel, and share with your friends if you find it easy, useful, right? So with this, I would like to conclude this. Thank you, and have a nice day.